Thank you for coming today for this month's BIMXT network. We have actually transitioned a little bit. We are now going to be referring to ourselves as BIMXT Online, as BIMXT Network is kind of the umbrella of what we're doing now. So thank you so much for joining us on the online event. The online event is run by a board of advisors that you can all see here on my screen. I'm sure one of the wonderful advisors is sharing, Emily, so great, sharing the mural. So make sure that you get in there and join us and add information in here. Most of this you can actually come in and click on, and they are links. You can come in, maybe you want to link up with Andrew or any of the other advisors. Definitely recommend you do that. We are also on LinkedIn. Make sure that you join us on LinkedIn so that you can see all of our updates, all of our upcoming presentations, both online and live, as well as get all of the information regarding our monthly recordings that we post after the meetings. One thing I definitely want to point out before I move over to our tip of the month, which I'm super excited for, is first off, as usual, you can always get to our previous meetings. You can see we are really getting a wonderful library of videos here. All of these you can actually come and click on. You can see Allison's doing a little bit of housekeeping, which is awesome. We have switched to an every other month, so that you will see that we do have some months with no meetings. But all of these you can actually come in and get to the YouTube video. So if any of those interest you, Ryan was a previous presenter on augmented reality, so you can definitely go check out his previous presentation or any of the others. In addition, if any of you guys are on the East Coast, we have started live events. Hopefully we saw some of you guys there. You can see in August, we are kicking off some of our secondary live events. So please go ahead and register for those. Very exciting. Those are also led by a separate board of advisors so that they can focus on what you and your kind of area or region, what you guys really want to focus on. So without further ado, I'm going to migrate over to our presentation information. As always, this whole middle area is for you. You can see, please, at the very least, you can see some of our regulars have come through and added their name. We actually have a little bit of a coded situation here. You can see in the right-hand corner, we have some symbols just so that we kind of know what industry you're from. I'm BIM, so I'm going to take the one with the computer. Kind of BIM IT is that guy. I'm just going to migrate him over, fill in my name and where I'm calling from. You guys are really orderly, and I love that about you guys. But in addition, please come through. If you have any questions for any of the participants, please throw them in here. I'm checking this. You can also throw them in the chat. I'll probably copy them over to the mural because this is captured. This is something that we can actually go back and refer to for previous meetings to make these and continue them to be great. So, Andrew, how are you today?
Good. How are you, Dana?
I'm doing so great. Thanks for asking. I'm going to go ahead and stop my share so that you can go ahead and share and hopefully tell us a little bit about yourself.
Yep.
And no rush. Yeah, definitely understand. It takes a second to get all of us joined. Hopefully all of you guys, I see adding your location. That's awesome. And any other information that you'd like.
So yeah, good afternoon, everybody. My name is Andrew Nguyen. I'm an applications engineer at W. Bowers. We're a mechanical contractor based in Maryland. We do work in DC, Virginia, Maryland area. Should I start off, Dana, with my
Yes,
spiel?
Please. And you're my neighbor. I didn't even realize.
Oh, awesome. So yeah, I'll be giving you guys a little tip of the month today. So basically, I wanted to be going over basically taking control of like all the opportunities that these new and upcoming technology software companies are basically providing us. And mainly I'm going to be talking about kind of the transition from the VDC BIM departments over to the shop, right? Because that's where a lot of the new, I guess, add-ons and additions to Revit and how you can leverage new technologies and tools to your advantage. If you're not familiar, I'm going to basically kind of do a quick rundown of like that process, just to get everybody on the same page. Basically, once how we're operating our VDC BIM department, they coordinate the model. Once that all those clash detection meetings are done, we move it over to our spooling department. And the spooling department basically breaks it up into smaller parts, as you see in the middle, where we have Revit. We have our title block set up, and basically right now we're using a software called MSpace to help spool those drawings out. And then once that's done, basically we can push that over into the shop, and those drawings automatically get loaded onto basically the Tiger Stop, the pusher where cuts can be easily made. And basically, if you're not familiar with the Tiger Stop or any the cutting softwares and tools, they can efficiently and quickly cut pipe and reduce the scrap. I'm going to pause there. If anybody has any questions, feel free to ask. If not, I'm going to go over kind of the more technical side of what is out.
Yep. Right? Doesn't look like we have any questions yet.
Okay. Sounds good. Like I said earlier, we use MSuites. They help us. They're basically a product management software that manages what is being pushed through our fabrication shops. So they help us. They start off with our BIM team, our spooling department, and then once it gets to the shop, we can track every assembly through a workflow stage process where we know when things get cut, things get assembled, and things get QC'd or shipped out. But this is the only option that you have. And MSuite does stuff with Revit and the Fab Shop managers, but also there's other companies out there that give amazing tools to help leverage, basically kind of make your life and quality of life for your BIM department and VDC team easier. And there's about, I'd say 15, including the ones you see on screen here, 15 different software companies that are out there that you can leverage to basically efficiently transfer that workflow as seamless as possible. So Stratus, Manufacton. I'm not sure if is anybody here working with any of these companies or has implemented them?
Yeah, if anybody has worked with any of these companies specifically, please let us know which ones. If you don't see them on the list, they're in the mirror.
Yeah. Yeah, I'd be pretty interested to know if anybody uses these. A lot of these are pretty big companies like Trimble. We have I'm pretty sure a lot of people use like Evolve if they're using AutoCAD. At least I'll Evolve tools to help just they have like little like things that make just life easier, like turning insulation off or turning the center line on and off. Basically, all these guys are out there to help you guys. But the main thing I kind of wanted to touch upon for this tip of the month is basically, I want people to know that there isn't like a best solution, I'd say. Not one company is going to basically work for every single company in the whole industry, right? Maybe you guys are more focused on going paperless, or another company is trying to do some data analytics. So each company has their pros and cons, and basically looking at the industry as a whole and seeing where the technology is going I believe is as important as the features itself. So on to my next slide. I'd say the best practice for kind of choosing what technologies, or maybe not choosing technologies. Like I said, you don't have to go with one or another. I say it's best to just understand where you're at. If you're thinking about going with or trying to improve your workflow and trying to streamline that process between VDC and the shop. So like each team, like you might have a big fab shop, but a small VDC team. So if you're going to do a whole change within your workflow and process in the fab shops, you have to make sure that the VDC team's on board as well. And really understanding what it takes to do that, and also what you guys are looking for. So a lot of these companies, their marketing teams are really good, right? They're advertising a very basically like a tasty product that looks really good on paper, but then you work on it and then you realize, oh wait, this kind of, I'm trying to stray from what I initially bought this for, or I have to conform to how they imagine the best workflow is. So keeping that in mind, and bringing it back to what I'm saying is that the best practice is you don't have to pick and choose one company over the other, but I'd say at the very least, best practice would be to look at all the technology companies as a whole, because they're successful for a reason and they're doing something right. But I'm not saying they're doing everything right, but like looking at where they're going, like if you're seeing a lot of these companies taking QR codes, oh, maybe QR codes are a good way to go, but maybe not. But like as the companies like start going paperless, like just keep these things in mind and why these guys are successful and why these guys are pushing the limits of VDC shop implementations. And yeah.
Thank you so much, Andrew.
Yeah.
It's really wonderful insight. Well, thank you guys all so much. It looks like you're doing a wonderful job and all orderly as usual, which I didn't start. You guys started the orderly fashion, which is awesome. Every month we do pick out basically a winner, and we just randomly pick someone that hasn't won in the past. And it looks like this person who shared on the mural is Madeline Chu from Seattle, Washington. You have won a prize, and someone from the BIM XT network will contact you. So congratulations. And as I look here, we have some really awesome locations. We got the Upper Northwest, we have the UK, some really awesome people and locations that are sharing. So next up, from my own company, SmithGroup, awesome presentation with Dafeng and Dongyeop. How are you guys doing today?
Doing well. Thank you.
Thank you.
It's very, very wonderful to have you guys today. I will say I have seen this presentation. I'm even excited to see it again. It's a very, very interesting presentation. So I see your slide. You guys are good to go.
Okay, great. Thank you, Dana, and everyone joined the meeting today. I'm Dongyeop Lee, and I'm with Dafeng Kai to present the U.S. Coast Guard Maritime Center of Excellence project. Dafeng was the project architect, and I was the project designer for this project. We will focus on how parametric design workflows were utilized for the building enclosure of the project from the initial design concept phase through project completion. Without much ado, Dafeng will start with site context.
Hi, everyone. So this project site is right at the waterfront of the Coast Guard Academy campus located in New London, Connecticut. So, Coast Guard is essentially a maritime service. So the clients really want us to have this new building reflect their mission and become the bold statement, a gateway for the campus from the waterfront. Next slide. So you can see there's a huge drop. The grading change on the campus is generally sloping down towards the waterfront. So that means make the fixed facade of the building, the roof actually become a very important feature during the design. And this is the shot we took during the construction, but you can get a sense of the building geometry and the massing in the actual context. So in the presentation, we will dive into more details on how this geometry was generated. And very quickly on the planning. So this is a 20,000 square feet building, 2 stories, and accommodate to several multifunctions. So on the ground level, on the upper deck, we have a welcome center, classroom, and offices. So the main body of the building actually is due north because the direction North Star has a very special meaning for the Coastal Service. And on the ground level, there's a double height boat shop on the backside. There is a science engineer lab and multiple labs and shops for the waterfront operation. The ground level actually angled to respond to the site, the driveway, and the waterfront bank, and creating a sense of arrival and also help anchor the building to the site.
So the design of the project was inspired by the sleek hulls and vessels under full sail, which represent the maritime heritage of the Academy. From the very beginning, we used Rhino and Grasshopper to explore various design options with hydrodynamic geometries. Every project has a limited budget, and this project was not an exception. And we had to come up with the idea of creating a unique and iconic design for the campus based on simple geometries. So using the Grasshopper script, we first set out a series of simple arcs as seen on this image. We then created points on these arcs using sine curves. Sine curves can be found in nature like ocean waves, and they were appropriate for the design concept for this project. The curves were created by connecting these points on arcs. They were then used to trim a barrel vault roof surface. So the trimmed barrel vault surface was the main driver to create the building enclosure geometry. So it might look complicated, but it is actually based on very simple geometry. So these curves were offset to form soft surfaces, and then we trimmed these surfaces at north and south, which are shown on the right and left side, respectively, on this image. We projected the bottom surfaces to the ground to create wall surfaces. We then divided those wall surfaces into 2 parts, the glass panels above and metal panels below. We created the glue lamp roof beams following the roof geometry, and we filled between the space between the roof beams with the ceiling planks. And finally, we created roof panels based on the covering the whole roof geometry. The entire building enclosure, with the exception of the deck at the north, was controlled by a Grasshopper definition, as shown in this image. The project was documented before the Rhino inside the Revit came out at the time. So we developed the custom transfer process from Grasshopper to Revit using Excel and Dynamo. I'm not sure there's a lag to play this video, but this video demonstrates how glass and metal panels were automatically generated in Revit by reading the Excel data. The Grasshopper was the main application for controlling the building enclosure design. The geometry was then transferred to SketchUp for visualization and communication within the project team. And the same geometry was transferred to Revit for the documentation by Dynamo and Excel. And right now, there's a Rhino inside the Revit came out, so the process is simpler than this. The structural engineer successfully created frames based on the roof surface we provided. However, we had to model exposed glulam beams for the documentation. Those beams were transferred from Grasshopper to Revit automatically using the same method shown in the previous video. The work points were critical to describe the geometry of cotton wool panels. All these work points were also automatically transferred from Grasshopper to Revit. Additionally, tagging was automated by running a Dynamo player script. If you're trying to manually add these tags, and we had to kind of iterate this process. We had to optimize design, and we had to iterate the documenting process multiple times. So the automating these workflows were very helpful for us to optimize the design. The work points were also used for the roof geometry, and they were set at the interval of 3 feet for the north and south axis. The project team coordinated with the glulam fabricator to decide how to set up work points and parameters for glulam beams. We spent a good amount of time documenting glulam beams to minimize any potential construction issues. These tables display the XYZ coordinates of all the work points used in the project, and all these coordinates data was also transferred from Grasshopper to Revit automatically. This page shows a few diagrams of the roof and soffit assembly on the right side. The force colors on the soffit surfaces at the bottom indicate the range of deviation from flat planes, with red representing the highest deviation, and green being flat surfaces. Actually the most complex surfaces were soffit surfaces because they are double curvature surfaces. But we checked the deviation from flat planes, and they were all within the tolerance.
So just want to very quickly go over all the renderings we have. So this is the building you see from the waterfront. And this is from the waterfront access, you see the building. And this is you coming from the campus across the railroad, you're gonna see the building and where the main stairs. And this is the backside of the building where we have this double height bow shop maintenance shop. And this is the interior. You can see we have the heavy timber structure and made the reference to the traditional way people make the boats and all the terminology all exposed to beam. So this is the timeline photos we took showing some critical phase during the construction, from very beginning, the steel structure erection to the metal deck installation and roofing, and last page showing the final finished roof panel start installed. And next slides, this was taken early this year, February, when we went on site and see all the lighting installed and tested on site. I tried to pair the photos I took during the February with where the rendering we show, so you can see the consistency between the design and the final products. So this is again coming from the campus across the railroad. And next one showing with the lighting on that day. The next is showing where you access the building from the waterfront. And again, with the lighting on. And this is the backside of people still working on the soffit on that side, and that's where the double height bow shop maintenance is. And this are a few nice shots with, with the help of this lighting, actually the unique geometry of the building and the massing, the texture was magnified. The next slide, I have a few more nice shots. It's just like, I have to admit, I'm very addicted to those photos because really the lighting helps to showing the geometry of the building. And this is the interior shots we took. And you can see all this exposed heavy timber, how they're relevant to the boat shop structure, the boat structure. And I want to pause here a little bit because, from the drawing to the finished products, as architects, we mostly rely on the submittal review to control the process, make sure the design was properly executed on site. But this project is especially unique because all this parametric design process. So even though we bring the contractor on board during the design phase, we talk through all the design intent, but really to carry that intent into reality is a challenge in a very different level, right? So if you think about the building as organic body, so I try to categorize all the submittal as 3 types. So the very first one is a bone. It's about including the foundation, concrete slab, the steel structure, which we're showing here. It's actually set up the basic framing for the project. So all the steel columns is in a 12 feet spacing, compared with all the finished panel, we have every 3 feet spacing and the segment. But, without setting up all the structure on the right location, on the right height with that grid, you're going to lose the whole reference point for the whole construction. So this is very critical submittal. And next slide. A second category of submittal that I would think is a muscle of the project. And this one, which is co-form metal framing submittal, is the most important one for this project because we rely on the co-form metal framing to frame the whole building facade with every 3 feet segments for the project. And that's basically, you need to lay out all the structure on the plan with certain segments, and you almost set up the certain height. So they match the metal panel and the curtain wall height. So that where those XYZ kick in, and you need to review all this information compared with our documentation. And next slide, it's also same thing. We also rely on co-form metal framing to form this compound curve on the soffit. And so we have to, based on our detail, to pick certain key point, and then the contractor can use that key point and set up XYZ coordinates. And then we can compare their coordinates with our data point in documentation to make sure everything consistent with our design. And the third category in the submittal, I would think, is scheme, right? Because now you got to the finished products of the project, you want to make sure everything comes together nicely. And that's, like most of the project have, we do this mock-up to make sure all the detail looks right, everything comes together nicely before we really apply all these things into a real building. And a lot of detail is at this level you need to pay attention. For example, for this project, we have the seal of the curtain wall continue stepping down to form the curve along the building facade. And then you need to think about, okay, the review of the metal panel cannot be aligned with the center of the curtain wall. Otherwise, people cannot construct it. So we have to make sure all those review align with the one side of the molding so you can make every detail constructible. And again, like on the roof, you need a gutter, how we can conceal the gutter nicely, follow the geometry of the roof curve. And there's going to be a snow guard, there's going to be a snow rail, and you can see from the photos, the snow rail follow the geometry and with a similar segment. And also the snow pad actually try to, barely visible from the photo because they all align, they are at the one point of the diamond shape of the roof tile. And last but not least, of course, the lighting is very important for this project. How you can detail the lighting, given the certain surface, they can mount it without conflicting with the building geometry, and how you can conceal at both top and bottom, but make the lighting complementary to the building geometry, but not conflicting with the building geometry. And this is the last photo I want to add in the end, because this project would not look like this without a great contractor actually took ownership every step of the way. This photo I received from the one day at like 6 a.m. in the morning from the project manager, the contractor. They didn't even say a word in the email, but I can feel he's very proud of this project. And, you know, I just, I love this photo because we feel the same way. It's like every single party in this project needs to take ownership for this one. And so then we can carry the concept through the way to the completion of the construction. And with that, I think that's the whole presentation we have.
Well, I'll say that you're definitely getting a lot of compliments on how beautiful it is. It's so crazy how the real photos look like renderings, right? I mean, they don't. It looks like you plopped a tractor or whatever in the photoshopped it in. You know, it looks just absolutely stunning. Can you talk a bit about how you translated the geometry over to the fabricators in terms of some of the roof panels and things like that? I mean, did you share the actual models? Were they getting, you know, the Rhino, the Revit, those types of things? How are you translating that to them outside of the shop drawings?
Oh yeah, well, of course, like Dongyeop said at the very beginning, like in the design, we have the panel size 24 by 24. But during the construction, we realized the maximum panel size we can go is 21 by 21 based on the availability of the materials. And then we have a talk with some fabricator, make sure they understand, you know, we want to start a panel centered with the roof geometries. And we set up several design guidelines for them. And then they can use the actual panel size and do their shop drawing. And then they send out the revised shop drawing based on our design documentation, and then we review that. And there's a back and forth. I mean, I think we reviewed the roof shop drawing probably 6 times. Unbelievable. Part of the reason because this building is waterfront. There are a lot of the code requirements, wind load you need to meet, and there are back and forth on that. But overall, you know, because it's not a typical building, it's a parametric design process. It adds another layer of the complexity to the reviewing of the shop drawing.
Interesting question. Did the state require the BIM? Did you have to send over the Revit model or anything like that? Or was it even, you know, did you required per the contract? I mean, I guess the Coast Guard wants it.
No, this is the project in the Coast Guard, which is a federal land. So oddly, like we don't design this building to meet state requirement. They don't review the drawing, but of course we try to. We're designing a building in Connecticut. We check all the state requirements. We gave all the Revit model to the contractor so they can use and pass that to all the subcontractor for all the information to share. But it's not required by contract. And honestly, like the Coast Guard, they only require CAD drawing. So we actually convert everything back to CAD for the delivery.
Yeah, sadly, I would figure, right? That's government for you. Looking back, right, hindsight's 2020, what would you guys have done outside of course, product and software advancements? Right now we have Rhino inside, we have a few other tools that SmithGroup is using that might have made the process smoother. But is there anything else outside of that you might have done to just done differently in general?
I'll leave that question to Dongyeop.
Yeah. I think the process could be smoother because right now the the transfer between Grasshopper and Revit is simpler with the Rhino inside, and also the proving ground had the app conveyor to make it even easier. But the one thing that we kind of had issues was it was a small issue, but we had to there's another person touched the Grasshopper script, and there was a point that we had to track the kind of the change between the different versions of Grasshopper files. So I think when you do this, you probably need to freeze the document, the model, the Rhino model and Grasshopper script at some point, and use that as a reference point. I mean, it's not just for Grasshopper or Rhino files, but for documentation, you have to set up that kind of a reference points for every change. I think that is something that I would recommend to everyone who's interested in this process.
And it's just so, I mean, it's so incredible the way that like you're saying, the snow cleats and the gutter and all of that was fabricated as part of that process. I mean, that's just, mind blowing. What was the wood that was used, the material itself?
You mean the wood structure? What wood used?
Or the wood paneling on the exterior? What can you talk to any of the materials that were used? Or the interior? Maybe they're talking about the barrel vaulting.
Yeah, the actual structured wood is glulam beams that come from Canada. So yeah, but wood cladding itself is I think it's a Brazil teak. The reason we use that is because most boats in old days was made with teak. The major donor of this project think we need to use exactly the same wood for that specific reason. And
that was another case, right? Is that the donor was they wanted it to be kind of a innovative structure.
Right. He pushed us to this innovative design process because he really wanted his building to celebrate the mission of the Coast Guard. And that's why the boat geometry, structure, and everything, we kind of try to relate to that concept.
I'm guessing Kobe was not required because no state mandates, right? I mean, if it wasn't tied to the state, I'm guessing it wasn't Kobe. No,
no,
I wouldn't think so either. Was it LEED? Did you do any LEED certification or anything like that?
It is LEED silver for sure. We're trying to get LEED gold. We're in the final submission phase. So hopefully we can get LEED gold, and we're going to hit back in 2 weeks.
Well, I'll say this is an incredible amount of questions and comments for a presentation. I mean, like I said, I've seen this presentation. I could see it again. So amazing. So thank you. I
just want to add one thing quickly.
Yes, please.
For the future reference, I think, every project has a budget, as we have for this project. We try to create some complex look with a simple geometry. And we try to understand how we can use conventional construction method to realize that during the construction, to execute in the construction. So I think for any project team, you have that mind. Of course, if you have a lot of money, you don't even care about money, that's a different story. But every project has a budget limit. If you want to make sure your design concept can be executed in the real construction, you want to bridge two things together, try to find a middle way to handle those complex things and merge that into a conventional construction method. I think that's just one strong feeling working several years on this project, what I got, and just want to, just say that aloud to anyone want to keep using the Dynamo and the Grasshopper as a design way. but have sometimes don't know how to make the real project use that method.
Well, thank you again. Amazing presentation. Dongyeop, Dafeng, thank you so much for your time.
Thank you.
Next up, we have Ryan. How are you today?
Good. All right.
Hopefully you will tell us a little bit about yourself in addition to the presentation.
Absolutely. So today I'm going to talk about a little bit about kind of MEP for prefab, similar to what Andrew was talking about. So a little bit about myself. Went to school at Clemson University, got my degree in construction science and management. Went to work straight out of school for Turner Construction, learned a lot. Had a little bit of time in the, with BIM, being a BIM manager, had a little bit of time in the field, just enough to know that I hated it. And I duly respect superintendents in the construction side, but just learned I was better behind a computer. And that's kind of where I've spent, my last 6 years or so. We've done now with BuildingPoint, did 3D modeling as a service. So that's kind of where I've gained a lot of the knowledge that I'll be sharing today, about prefabrication. So I live in Raleigh, wife and 2 kids, and, I just put an Atlas Works logo in there just for coordination. But, I guess along the lines of, where kind of my prefab journey and what I've learned, when I first kind of got into the industry, it was like 10 years ago, and it was, seemed intimidating, prefabrication. So my first slide here is, don't be intimidated by prefab. Like, this was my, this is what I'll, call modular construction, where you have kind of more big scale elements inside of a building. So, don't think that you have to, start here, right? So that'll be kind of a theme throughout the presentation, is like, start small and kind of find gradual success as you go, kind of throughout that prefabrication journey. So for those that are on the construction side. So MEP prefabrication, it's, or I guess prefab in general isn't new in the industry, right? You think about, the subcontractors or, trade workers that have been doing things in a shop. You don't see a mill worker pulling out all of his, laminate cabinet, countertops and sides and, manufacturing, kind of a base cabinet, for years before kind of, before the MEP got into prefab, these guys have been doing that in the industry forever. Same thing with steel. There's certain kind of things that you can do in the shop. You don't bring a raw piece of steel, and shape it on a site, right? You've got to kind of bring it, to a shop somewhere. So, just keep that in mind. Like, to some extent, there's a little bit of prefab in everything. You don't just take raw, you don't take a raw, tree and bring it to the construction site. So, hopefully that encourages, those that are not in it, too deeply. You're basically just kind of taking, different components and bringing them, on site. So, I said here, this is a hot take, I guess, debatable, but I said BIM is a prerequisite to successful prefabrication. You don't have to do BIM. If you are an MEP, contractor, like piping, and you've got a whole mechanical space to yourself, you don't really have to do BIM, as long as, you understand all the constraints in that room, and there's really nobody else in that space to, coordinate with. We've, one of our trade partners, when I was doing modeling, that we'll, talk about here, they did a lot of kind of spool drawings by hand. And, I was amazed by that. I was just, this guy has, 20, 30 years of experience just drawing by hand. And, we kind of came in with this new age technology, doing things, based on the 3D model and all that. But, the process is kind of just like anything else, independent of the technology itself. So I put the caveat there, or at least going to a high LOD and LOD. I always have a running joke that LOD is not equal to LOD. Development and design are actually very, very different. That's kind of I do a whole presentation about that. But, you know, level of development is basically saying this is where I intend to put something, right? And that's exactly what prefabrication lends itself to. You know, the level of detail that you kind of get into that can vary kind of depending on, you know, how much value that you want to extract from that. So like I said, the definition is just the practice of assembling components of a structure in a factory or other manufacturing site, you know, and transporting complete assemblies or sub-assemblies to the construction site. So I kind of put a few kind of different visuals around this just to kind of show you, you know, like I said, you don't have to do modular. You don't even have to do the two on the right, skidding and racking, you know, kind of what Andrew was talking about earlier. You know, you can just start with spooling. I mean, you can see these, you know, these sub-assemblies aren't huge, but they are, you know, we'll talk about kind of the benefits later on, but they're easy to kind of start from. And like Andrew said earlier, the technology, and we'll kind of get into some of that, the technology really lends itself to enabling a lot of this. And there's a lot more, you know, when you start going to a higher level of detail in your models and your drawings, you can start extracting a lot more value, you know, even beyond kind of the spatial, you know, the spatial computing of it. So skidding, you know, kind of in the middle there is, you know, this is typically, you know, the MEP only, you know, if it's in an MEP room, you know, this just kind of benefits it where you can, you know, just take a lot of stuff, you know, put it on a skid and just drive it in a building. You know, I've seen these things lifted into buildings using heavy duty cranes, you know, and then I'll say racking on the right is kind of multi-trade racking. That's kind of probably the most complex one because you're actually starting to think about, you know, it's kind of this coordination effort in the shop, right? You're, you know, whereas spooling can kind of be done, you know, if you're electrical or mechanical or plumbing, you know, in your own shop, you know, can kind of brought in like Legos to the, you know, to the shop or to the site, you know, multi-trade racking, you know, kind of has a little bit more to it where you've got to actually start thinking about load, you know, because you can see there's, you know, you're adding kind of an additional piece of structural steel, you know.
So that's actually what we had our last round of local meetings on was Atrium
Nice.
Health and their racks that they did for a hospital project for Atrium Health, as I mentioned. So we may get that one online and recorded. But can you talk to another project that you've worked with or that you've seen that used, or maybe you'll get to it?
Yeah, there's one right here. So
awesome.
This was a project we did with some of the team member, or I guess board members at Clancy. Shout out to Zach. He was the BIM coordinator on this one. I was doing modeling and for Warwick Mechanical Group. So this was a project, and they actually sent me a plaque. Hampton Virginia Aquaplex over there, kind of by the coast. So, you know, we kind of went through all the coordination. We had this the two images on the left kind of you know, show the timestamps of essentially, you know, I just kind of, as it's nice to have, I think all the BIM people out there like can appreciate this too. You know, when you have something, you know, like a webcam on the site, it's like, you know, it just kind of gets that intrinsic feeling of like, okay, you know, I did something, a part of this project, and you can kind of start to visually see it. So that's an interesting side note. But, you know, I think one day I was like looking in the morning and then like look back later that day and I was like, oh man, they put in a lot today. And I started kind of just seeing, okay, like how long did it take them? And like literally like I put the timestamps there and, you know, just to show like within 30 minutes, you know, they basically took, you know, this kind of whole bathroom pod area, or, you know, kind of that main spine there that you see. And I have some screenshots there of the model and then what the spool drawing looks like. You know, they basically brought that entire thing in and just plopped it in, which I think there was like a delay because of weather. And they were actually, you know, it helped them kind of not to avoid like a schedule delay too, you know, because they were able, you know, they were doing prefab and, you know, it's like, yeah, we're good, you know. So that was a kind of a fun one. But all that to say, like, that's just PVC, you know, like PVC is easy to work with, you know, it's bigger in size, but there's still benefits. You know, a lot of people, you know, probably wouldn't start with PVC as a piping contractor. You know, you'd probably do something more like this, spooling of steel pipe inside of a mechanical room. So this project was same sub, Warwick, GC was the other, it's on the tip of my tongue. I'll get it later. But anyway, so similar process. So, you know, can't remember, I think, you know, we are kind of a Trimble house. So we specifically use Siskiyou for most of our projects. So you can see, you know, the kind of the level of detail that we, you know, go to on, you know, on the modeling side, you know, even showing kind of the exact thickness of that weld and leaving a gap and all that, and really collaborating. You know, that's one obviously huge part of the process is collaborating between the office and the field side and really saying, hey, you know, what are we doing here? You know, what do you prefer? You know, there's different options, or, hey, that's not going to work. You know, we've got a certain head height. We've got, you know, a certain suction distance we need off a pump. You know, what are you guys, you know, you really got to like delve into the details of the submittals to really make sure that, you know, all the T's are being crossed and the I's are dotted. In the center there, you can kind of see that was like kind of early stages of, you know, going back to my AR presentation, you know, kind of overlaying digital geometry on top of, you know, the real world. We kind of did it there in the prefab shop. And then on the bottom right, you can see he was the BIM coordinator for that project. So we brought him into that mechanical room as we were doing the installation and kind of showing him, hey, you know, like, this is, you know, this is what kind of has to go left, you know, showing that whole room, you know, but how detailed we had the model and how, you know, closely we were following the model and all that. So kind of getting a little bit into the benefits, you know, obviously there's one of the biggest benefit is cost, you know, for a trade partner. You know, you just kind of look at kind of hangers, right? I mean, even if you just started, you know, spooling your hangers, I think that's a great starting off point. And then obviously you can, you know, use different things like total stations to like put the hangers in the deck beforehand, and like all these different things that are, you know, becoming commonplace in the market. But just kind of looking at the figures there, I mean, depending on a job size, you know, you're going to start saving, you know, tens of thousands, if not, probably not hundreds of thousands, but probably tens of thousands of dollars on a big enough project. You know, and the added benefits of safer working conditions. So, you know, fewer ladders, less, you know, drilling, less work overhead, you know, so there's a lot of exoskeleton things, which are cool, but it's like, well, what if we just took a lot of that work into the prefab shop, you know, and kind of avoided that exposure as it was. More productive, obviously, you know, you're not kind of in a controlled environment, you know, you see exposure to weather there, you know, the hot heat of, you know, especially here in the Southeast. And I mean, you know, it gets hot in a lot of places of the country, a lot of places it gets cold, all those things. So, you know, it really brings it into a controlled environment, which people are then more productive. And then, you know, certainty to the schedule. Like I said, on that one, we were able to not have any scheduled impacts due to, you know, the fact that a lot of things were already done. You know, you basically just kind of have these, you know, these weld points in the field, you know, for the steel pipe, and then, you know, for the PVC, you know, those are a little bit easier to go along. And then reduction of waste, you know, on the construction site. I mean, sometimes think like, if you've never been to a construction site and you're on the design side, like highly encourage just, you know, kind of unannounced, just kind of go walk construction site. You'll be surprised. You know, things get lost, things get, you know, mangled, you know, but a lot of times, you know, if you have a good enough plan, you can essentially, you know, reduce a lot of these, you know, wasted materials and things on site as well. So, and then obviously improve quality. And then, you know, at the end of the day, you're kind of winning more bids and winning more work and being more profitable. So just like Andrew had, I've got some, a ton of options. I put them in the mural there as well. Just saying, hey, there's tons of options out there. None of them are perfect, like he said as well. Like, we rep Trimble, and I know we're not perfect. Like I've heard, it really just depends on, what trade you're doing. Some are stronger in, certain trades than others. But all these, kind of, I put plugins because really a lot of them are basing, around kind of, Autodesk authoring suite of AutoCAD, which is translating more now to Revit. There's others out there, kind of on the authoring side, but you're at least here in the States, a lot of what we see, are just kind of plugins to Revit as an authoring tool. So, and then just a couple of these animations. I think he talked about the tiger stop. This is just kind of an animation of what the tiger stop is. So, you have all this I and BIM, right? Like that used to be a buzzword. Now it's actually like, now we have new buzzwords like digital twin. But this is kind of the I and BIM, kind of come to life, right? Where it's, you have all this information that's in the model. And you can see that cut end right there. Like that's your waste. So it kind of goes through and, all the algorithms can kind of crunch the numbers. You can put like your pipe length in there and it can say like, okay, like cut this one to this one. And then you're like putting, specific pieces of, stickers on there to essentially, show, hey, this is where this part and piece goes. And then you can start, wrapping those in kits and like delivering them to the site, as kind of, as you show there. So like, this is even, you don't even have to be spooling to kind of do something like this. You can still just take the information from the BIM and kind of do something like that. And then for the electrical folks, it's overlaying. There we go. Just automatic benders of pipe, conduit, different things like that, where you really can take the guesswork out of it and really enable your teams to be set up for success. So that's all I got.
Looks like there's a few questions regarding the kind of relationship that you had with the A&E, architects, MEP, those types of people within the scope.
Yeah. So, a lot of the contracting methods, I think were not design build. A lot of what we did as a third party is more like a design assist. It really it depended more on the relationship. And I think Dan Morin has a whole presentation about this. I think he did it at like a Clemson BIM symposium one time, but it really, don't ignore the contracting method, but as long as you have a good relationship with the teams, that's really more what it's all about. And showing that, you give a crap and like you want to do something with excellence. I think, as long as everybody's really striving for that, then I think that's the goal. And, I've never really been a part of a project that has had true co-authoring, from like design to, down to the MEP side. Those are usually say for, bigger projects and things like that. So I haven't had that opportunity, but knowing that exists, there's definitely a lot of benefit to working together.
Absolutely. Are you doing any post-install scanning to confirm install? Seems you mentioned digital twins and
yeah. On these, no, I was using, kind of utilizing the AR MR technology more for that. That's actually kind of how I got my start with that stuff, was like I was modeling all this stuff, and occasionally I would go out to a site and I would just bring my iPad or bring my HoloLens and just kind of use that as like, hey, are they like generally putting this stuff in, where it's supposed to go? And like throughout my 6 years, there was a whole gambit. Like some people, like this project, we'd had like, usually we found like the higher LOD that we were going to, modeling in hangars and, all giving points and all this stuff. Usually those were the ones that, I found in the HoloLens, like, oh yeah, they're they're installing like exactly like I did, like we showed it, and those were the ones where there's like a whole process where, we got their feedback, and that's a huge piece of it. Some of the projects may have been faster, a lot of different factors that kind of go along with that. But as far as, there was one project, I'll say, I won't name companies and things, but yeah, I looked up and I was like, this is nothing like what we drew. Then you're just like, why did we even go through this process?
Right.
So, but yeah, we didn't, we haven't really done any scanning. Scanning is getting to that point, when you start talking about integrating robotics, like Spot the Dog and things like that, where you're kind of doing that digital capture on a consistent basis. The struggle that we have now is like, how do you manage all that data? And then kind of what software are you kind of using to cram all that in? So there's some solutions out there. Obviously, Spot's not cheap. You don't have to do Spot, but then you're hiring somebody to scan every week or whatever.
Sure.
Scanning is kind of,
we are right at 2, actually.
Yeah,
but I feel scanning could probably be its own topic in of itself, right? Thank you all so much. All of these presentations were so fantastic. Thank you all to the presentations for your wonderful questions and participation on the mural board. And we look forward to seeing you not only online in 2 months, but in our local live meetings. So see you guys all then. Thanks for joining.